Well, hello guys, here Mr. G with another video. This time we're going to be answering an acid-base reaction question for the grade 11. However, it's also applicable for grade 12. I will leave the question in the description below so you can answer before watching the video. But don't forget to subscribe for the channel so you can get all the notifications and videos I post on regular basis. This question says, consider the following ionization reaction of HCl. And then you can see that hydrochloric acid ionizing water to form ions of chlorine and hydronium. Question 6.1.1, define an acid in terms of the Lowry-Brønsted model. And guys, if you say that an acid is a proton donor, you will get the 2 marks. It's quite simple. It's a substance that donates protons. Which one? Write down the conjugate acid-base pair. So let's do the following, let's do all the steps. To do this one, we have to identify the families. You can see that HCl and Cl are families of each other. You can see that they look alike. Or let's say they have something in common. Now, what happened? From the reactant to product, one H is gone. Therefore, it means that this one is the acid, but you know that. And this one is the conjugate base, alright? And then the other families are H2O and H3O plus. The other families are H2O and H3O plus. And what happened from reactants to product? You see, one H was taken in, therefore this one is the base, because it took a proton as it goes from reactants to product, and this one is the conjugate acid. Alright, so we have now identified the acid-base conjugate pair. So you can say, or you can write it in such a way. For example, you can say HCl, let's use another color, HCl and Cl minus, that is the first acid-base conjugate pair, and the other one is H2O and H3O plus. This is how you write the acid-base conjugate pair. They say write only one. So if you write either of them, you will get 2 marks. There we go. Write down the formula of the substance in the reaction that can act as an ampholyte in some reactions. And in this case is water. What is the substance that can react as an ampholyte? Remember, ampholyte means it can act as an acid and base. Sometimes it can react as an acid and another time can be a base. That is the meaning of ampholyte. And that was the first part of the question. If you say that, you get another mark. There we go. There's 1 mark for that. Question 6.2. A certain volume of hydrochloric acid solution of concentration 0.5 mole per cubic decimeter is added to a sample of seashell of mass 8 grams in a container. The hydrochloric acid solution completely reacted with the calcium carbonate in the sample according to the balance equation. It means that the hydrochloric acid was gone. Right, all reacted with the calcium carbonate. So all the calcium carbonate was also reacted according to this equation. And then you have the equation that the seashell contains 95% calcium carbonate. It means that it's impure. They telling you at the beginning of the question. Is the reaction endothermic or exothermic? And give a reason for your answer, guys. They're giving you delta H is negative. Just as a recap, delta H is equal to the H of the product minus the H of the reactant. Alright? For it to be less than 0, it means that the H of the product must be less than the H of the reactant. Alright? In other words, energy is released. Alright, therefore this one is an exothermic reaction. You don't have to say all that. All you have to say is an exothermic reaction because a delta H is smaller than 0 and you will get that mark. Alright, however, alternatively, you can say that the energy of the product is less than the energy of the reactant, or you can also say that energy is released. Either of them will give you 2 marks. One for identifying, one for saying it's exothermic, no endothermic. Exothermic, I say exothermic, I mark the endothermic one. One for saying is exothermic, and one for saying is delta H is less than 0. And to final this one, calculate the volume of the centimeter cubic in centimeter cubic of the hydrochloric acid that was added to the sample inside the container. Okay, so what is the first thing we know here? We know that they add 8 grams mass of the seashell. Mass of the seashell, I'm going to write here, seashell is equal to 8 grams. Alright, but now 8 grams is not the calcium carbonate, it is the mass of the seashell. Now we know that the seashell is equal to 95% calcium carbonate. Alright? So out of the 8 grams, how much is going to be real calcium carbonate? So we're going to do percentage calculation here. Okay? We said 8 grams represent 100%. Alright? So 95%, how much will it be? And we do a cross product here, guys. We do a cross product there. That will give me that the mass of the calcium carbonate will be mass of calcium carbonate Ca CO3 CO3 inside the seashell will be equal to 7.6 grams. Now we know what is the mass of the calcium carbonate that reacted in the reaction, because they say that the hydrochloric acid solution completely reacts with the calcium carbonate in the sample. So all the calcium carbonate has reacted in this sample. So we are going, now that we know the mass of the calcium carbonate, we are going to calculate the number of mole of the calcium carbonate. So we have to calculate the number of mole of this calcium carbonate mass divided by molar mass. What mass? The 7.6. We cannot use the 8 because the 8 is the whole seashell, which not everything reacted, only the pure calcium carbonate. So this one will be a 7.6 divided by the molar mass of calcium carbonate. Remember, you need to go to the periodic table for the calcium carbonate. Calcium is 40 and carbon is 12 and oxygen is 16, so it's 3 times 16, and this one is a plus in between, so it's plus 12 plus 3 times 16. That is how to calculate the molar mass of those compounds. We can take off this bracket there. There we go. And then the answer, when you do this one, the number of mole of the calcium carbonate will be 0.076 mole. Alright, so now we know the number of mole of the calcium carbonate that reacted here in the equation, this one here. So what we're going to do now, we need the hydrochloric acid because the question is about hydrochloric acid. So we're going to be using the ratio. So we're coming here and we say ratio. Ratio of the calcium carbonate and the hydrochloric acid. Remember, at the numbers at the front, and we have is 1:2. So I'm going to write here ratio of CO3 to HCl. That is the ratio I want to look for, and the ratio is 1:2. It means if we get 0.076, how much are we going to get here? No, once more you can do the cross product, but this is quite simple. This X, which is the number of mole of the hydrochloric acid, will be equal to 0.76 times 2, and that will give me 0.076 times 2. That will give you 0.152. So now we know the number of mole of hydrochloric acid. All we have to do is to calculate what they want, and they want to calculate the volume of the hydrochloric acid. They also giving you the concentration. So the formula we're going to use is the one for concentration. And that will be the end of the question. So number of mole is equal to, concentration is equal to number of mole divided by volume. And I'm going to substitute right in the equation 0,5 is equal to the number of mole. We got 0,152 divided by V. When you rearrange this one, you get that V is equal to 0,152 divided by 0,5, and then you get that the volume is equal to 0,304 cubic decimeter, but we are not done because the question say in centimeter cubic. So the final answer must be in cubic centimeters, and to do this one we have to multiply by 1,000. So the volume, there we go, the volume is equal to 0,304 times 1,000, and that will give you 304 centimeter cubic, and that is the answer of the question. The marks here, they gave 1 mark for deduct the mass of the pure calcium carbonate, 1 for this formula and this substitution, 1 mark for the ratio. There is always mark for the ratio, guys. There is always going to be mark for the ratio, 1 for this formula, 1 for this substitution here, and 1 for the final answer converted to centimeter cubic. Guys, I think this is all. This is the end of the video. I hope it helped. It's a quite very good question to practice for the exam. Thank you for watching. Thumb up, subscribe for the channel. I'll see you next time, Mr. G.